Okay, now we will talk about box plots, and this is what they look like. I have some information here which you should read, but I'll summarize what box plots are. So, the body of the box plot is this rectangle right here, and then it has these two whiskers, and data above this whisker at the top and data below the whisker at the bottom are outliers. So this box is bounded at the top and bottom by specific percentiles. So at the bottom, you have the first quantile, which is the 25th percentile. At the middle, you have the median, which is the 50th percentile. At the top of the box, you have the third quartile, which is the 75th percentile. So that's the meaning of the top, bottom, middle, and then the whiskers. That's what they represent. So it gives some statistical summary of your data. And this is the one line Python command that generates this plot. It's the name of the data frame dot plot, and then you specify the kind of the plot you want. So we want box plot, so you say kind equals box. We can create a second column to this data which we imported, right? It has only one column, which is cumulative production NP. This other one is just an index. It isn't part of the data. So we create a second column using the square bracket. Remember, this is how data frames work. To create new columns in your data frame, you just put the name of the data frame, square brackets, and within the square brackets, you put the name of the new column in single or double quotes. So we're creating it from the only column in the data frame right now by adding that data to random numbers. So 1 is 6, which is 1 million, multiplied by this random number, which will be between 0 and 1, right? And then we're asking for a column with these many rows. So we are grabbing the length of the current data frame and the index of that, and then we use Python's length function for the length. So the length of this new data frame matches the existing one. More importantly, the length of this modification to the existing column match. That's the only way you'll be able to add them together, right? You can't add a column vector of length 5 to a column vector of length 100. The lengths have to match. And then you can look at the first couple items with the head, precisely the first 5 items. And then we can generate the plot with np data frame dot plot, and the kind equals box. And now you will have two box plots. The first one will correspond to the np column, whereas the second corresponds to the second cumulative production box plot, which is this. And then you can see those labeled right here. We can generate these histograms using same np data frame dot plot function, but with kind set to hist for histogram. And then you can specify that the histogram should look like steps, and the bin will dictate the number of these kinds of steps you will obtain. So you can play with these, change these values, and then you see the resolution on the steps will change. Here we show two types of histogram. So the standard one, which is the one from this single command, is what is shown here. It's pretty much the histogram. And then this orange looking curve is actually the PDF, the probability density function. And the main difference is that with frequency, we just count the number of occurrences, and you see these numbers are big. But with the PDF, you will have the numbers as fractions. And then when you integrate them, you will obtain CDF. So it's important to realize that in PDF, the frequency will be density, to be fractional numbers, whereas histograms can just show the number of points that fall within a beam. And so to get the histogram to have density instead of frequency on the y-axis, you need to provide this argument, density equals true. So you'll see that this histogram is actually different from this, because this has frequency going from 0 to 2000, whereas this is always less than 1. And then the orange one is plotted from the data frame.plot.density function, and this BW method stands for bandwidth method. And if you play with this, you will see the resolution on the PDF will also change. So feel free to experiment, and then you get a feel for how these plots change with these change in parameters. So we can plot vertical lines in our histogram using this function from matplotlib.pyplot. So PLT stands for matplotlib.pyplot because we imported matplotlib.pyplot as PLT. AX V line, the important point is the V for vertical line. So axis, vertical line, and that will give you these. I mean, you see there are 3 of them, right? So each one corresponds to these 3 lines. The first one is at 10th percentile, right? Quantile 0.1 for 10th percentile. The color is some cyan, which looks like orange, and then the line style is dotted lines. So that's precisely this one. So at 10th percentile, the cumulative production is a little less than 0.8 million. Actually, this is 1E7, so it's at 80. No, it's at 8 million barrels at 10th percentile. We can draw another vertical line at the 50th percentile as shown here, and that, because you don't provide line style, will be solid by default, and that's the middle line right here. And lastly, we use the quantile and provide 90% here, and that gets us this third vertical line, which is indicated by this column. So the column gives you gets you this type of dotted line, whereas these 2 dashed lines gets you this type of dotted line. So they are different, right? And if you don't provide any line style, you get a solid line. Plot.axis, we want the axis to go precisely the x-axis. We want it to go between the lowest number in the data, right, in the column of the data frame we're interested in, which is NP. So xmin, minimum x-axis, is the minimum from that column, and maximum is the maximum from that column. Remember, we're using the max function from the data frame. Very important to note that these functions need to end with these parentheses, opening and closing parentheses. And you can save this plot to the current directory where this file is located by using plt.savefile and providing the name of the output file. So these 2 are histograms, or better still, they are PDFs, right? They are probability density functions because density is set to true and the y-axis are fractional numbers, but this is the histogram where the y-axis is real values that could be bigger than 1. So to move from the PDFs, the probability density function, to the CDF, cumulative density function, in Python is as simple as adding another argument and setting cumulative to true. So it will integrate the equation for the PDF which I had shown earlier, and then we obtain this plot shown here. plt.axvline, right? We talked about that previously. We have 3 vertical lines and they are shown here like before, and now we also add h line, so axis horizontal line, and we want it at 10%, 50% and 90%, and those are these horizontal lines here. And you can see this is 0.1, which is 10%, this is 0.5, 50%, this is 0.9 for 90%, whereas these other ones took the quartile as an argument because we want the data that is at the 10th quartile, right? And so those are vertical and they correspond to these values on the x-axis. Now some very important comments on CDF. The CDF is the probability that the cumulative oil production is less than or equal to 1.15 E7, meaning 11.5 million barrels is 90%. So let's see that here. So 1.15 E7 is about here. This is 1.0, this is 1.1 at the middle somewhere. So this is 1.15 E7, and that corresponds to what percentile? 90th percentile. And remember, these CDFs were obtained from the area to the left, right? The ratio of the area to the left, this area to the left of this dotted line, divided by the total area, right? That's how we got it. So because it's the area to the left, is the probability that the cumulative production is less than or equal to this value. That is the key. Just run it so it still shows this way. So that's the key. So it indicates that the probability that the cumulative oil production is less than or equal to 9.63 E6 is 50%. So 9.63 is right here. That's 50%. So less than or equal to, that's what it is, because the CDF is the area to the left of that line from this figure. And lastly, for the 10th percentile right here, it shows that the probability that the cumulative oil production is less than about 7.8 million barrels is 10%. And then in terms of P10, we'll see what that is from these comments. So we can reward these 3 statements which speak to the 10th, 50th and 90th percentile respectively. The first remark we can make is that the probability that the cumulative oil production is at least 1.15. At least 1.15 means 1.15 E7 or greater. So probability that it is at least 1.15 E7 will refer to the area to the right, right? And you already know the area to the right from this curve is precisely 1 minus the area to the left. So that probability will have to be 1 minus the 90th percentile, right? So 1 minus 90% is what? It's 100% minus 90%, which is 10%. And that is the P10 estimate. And we typically use this in reserves management, petroleum engineering. So P10 is the probability that the oil production is greater than or equal to the value at the 90th percentile, which is 1.15. You can also say that the probability that the cumulative oil production is 9.63 E6 right here is 50, which is 1 minus 50%. And lastly, we can say that the probability that the oil production is at least 7.83 is going to have to be 100% minus 10%, which is 90. And so, very important to realize that P90 is actually 1 minus the 90th percentile, right? Which is the 10th percentile. Whereas P10 is the 90th percentile, which is 1 minus 90%. So when we talk about P10, P50, P90, we're looking at the area to the right of the points chosen divided by the total area. So probability that X is greater than or equal to, or probability that X is at least the given value on the x-axis, whereas the percentiles are interpreted as the areas to the left, like I explained earlier. And we'll stop the video here and continue from there.